Okay, so I've had a question about using inequalities in frequency tables. So I'm actually going to start off by talking about discrete and continuous data, which you've probably come across already, but let's just take a moment to think about that because that's going to be really, really important for this. So discrete data cannot be shown as any decimal or take any value. So what I mean by that is if I asked how many students there are in the class, okay, there might be 28 students, there might be 32 students, there might be 4 students. There are definitely not 4.36 students or 7.28 students, okay? It cannot take any decimal. It just doesn't make sense, okay? If I'm thinking about the number of cars on the road, okay, there might be 100 cars that drive past my house in an hour. There might be 200 cars. There might be 4 cars that drive past my house in an hour. There are not 4.5 cars. There are not 7.3 cars. There are not 15.286 cars. Okay, so that's called discrete data. Okay, that's called discrete data. And it's often physical things that you can hold. Now, continuous data is data that can take any decimal value, okay? So there's no kind of gaps in it. With discrete data, there's gaps, okay? It's 1 car, then there's a gap, 2 cars, okay? Continuous data has no gaps. So this is things like height, okay? You could be 4 centimeters. A line could be 4 centimeters long. It could be 5 centimeters long. It could be 4.5 centimeters long. It could be 4.32 centimeters long. So there's no gaps. It's continuous, okay? Weight. Okay, you might be 50 kilograms, you might be 51 kilograms, you might be 50.2387 kilograms. Okay, there's no gaps there. It makes sense to take any decimal value. Time, okay, something might take 10 minutes, it might take 11 minutes, but it might take 10.124 minutes. Okay, if you use the word less to describe it, it'll be continuous data. So you don't say, I'm interested in the height of all people that are fewer than 2 meters tall. Fewer than 2 meters tall, that doesn't make sense. You'd say, I'm interested in the height of people that are less than 2 meters tall. Okay, you wouldn't say it takes me fewer than 30 minutes to drive to work. You would say it takes less than 30 minutes to drive to work. So S, continuous, less, continuous, okay, and discrete is fewer. So discrete data has these gaps. Okay, continuous data does not. Now, what we're going to be thinking about is continuous data here. Okay, so let's go and look at a frequency table. So it says a teacher did a survey of how many minutes her students spent on their phones in 1 month. Here are the results. So it's how many minutes. So this is continuous data, doesn't have gaps. So we've got our minutes here, and we've called that T, and we've got our frequency here. So remember, this is continuous data. So 11 to 20 minutes, there are 3 people. 21 to 30, 7 people. 31 to 40, 5 people. 41 to 54 people. 51 to 62 people. But this is a bit of a problem for us because continuous data should have no gaps, but there's a gap here between 20 and 21. What if someone spent 20 minutes and 30 seconds on their phone? Well, that would be in there. That would be a gap, okay? So this doesn't work for continuous data, okay? If it was discrete, if this wasn't minutes, if this was number of students, 11 to 20 students there, 21 to 30 would be there, that would be fine, okay? But because we're thinking in terms of discrete, because we're thinking continuous data, we can't leave gaps. And this way of setting up the table, which is in one of the homework questions, it leaves gaps, and we can't leave gaps for continuous data. So we've got a second approach down here. So if you notice, it's exactly the same here. I've got 11 to 20, I've got 11 to 20, and then I've done 20 to 30, 30 to 40, 40 to 50, 50 to 60, and the frequencies are the same. Well, let's think about that. This has solved our gaps problem. Okay, there's no gap between 20 and 30. Sorry, between this group, and there's no gap between this group and this group. There's no gap between this group and this group, no gap between that group and that group. Great, but what about someone who spends exactly 30 minutes on their phone a month? Where do we put them? Do we put them there? Or do we put them there? Okay, so here we had the problem of gaps. Here we've got the problem, not of gaps, of overlap, okay? 20 to 30, 30 to 40, well, the 30s overlap here, okay? So, problem with gaps here, okay? Problem with gaps here, we don't want to use that. Here we've got the problem with overlap. So we can't use that either. If you're 30 minutes, did they go there, did they go there? We can't use that. We have to be precise. Okay, so what we're going to do is we're just going to remind ourselves of something that might initially seem very different, okay, unrelated, and then we'll use that to kind of solve this problem. So inequalities, just a quick reminder. Okay, we've got inequalities that are like that, okay, that, and we've got that. So these ones, okay, are strict inequalities, the ones that I've put a circle around. These ones are non-strict inequalities. So strict ones, okay, this is a strict inequality. It means t is bigger than 3. Any number, t is any number as long as it's bigger than 3. But it does not include 3, okay? 3 is not bigger than 3, okay? So t could be 4, t could be 3.1, t could be 128, but t could not be 3, okay? This one is a non-strict inequality. This one says t is smaller than or equal to 4. So t could be 3, t could be 3.8, t could be 3.99, t could be -8, but importantly, t could be 4 because it's a non-strict inequality. It's got this includes 4, okay? This one, t is smaller than 10, but it could also be equal to 10. So it's, you might say 10 is bigger than or equal to t, or t is smaller than or equal to 10, but it's important to note that it's got this equal thing in. And these inequalities are going to help us solve this problem. So this is how I've set out my frequency table now, going back to those frequency tables earlier. Minutes, t, okay? So t is just the time taken. So t is just the time taken. The time spent on their phone. So this just means this person, okay, anyone in here, so there's 3 people in here, okay, there's 7 people there, 5 people there, 4 there, 2 there. If they spent 11 minutes or more, okay, so that's 11, 11.1, 11.2, 12, 13, 14, 15, 16, 17.2. So 11 minutes or more, but it includes 11, but less than 20 minutes, they go in here. Here, okay, and notice we've got 20 there, so we've not got those gaps. But we know if someone was exactly 20 minutes, well, they don't go in this one, okay, because it does not, the time does not include 20. It would go in this one, okay? So this one includes 20, okay? So that means, essentially it means between 20 and 30, but it includes 20. It doesn't include 30. So if someone went for exactly 30 minutes on their phone, you know straight away, well, this one doesn't include 30. They'd have to go in this one because this one includes 30, doesn't include 40. Okay, so this addresses both problems. We now don't have the gaps, 20, 20, 30, 30, 40, 40, 50, 50. We don't have the gaps, but also we don't have the overlap. Okay, if someone spends 50 minutes on their phone, well, we know straight away they don't go in that one because this inequality is a strict inequality. Okay, so it has to be less than 50. They go in this one. Okay, so I think the question says write the interval 11 to 20 using inequalities. Well, that's the way that you would write it. 11 to 20, and by convention, that end is always going to be a non-strict inequality at the low end, and the top end will always be strict, okay? And this applies for continuous data, okay? For data where we don't have gaps, we need to make sure we don't have gaps, okay? We don't have gaps there. And then we also want to make sure we don't have overlap. So that's how we sort of get around that. So remember the two problems we had? We had gaps, we didn't want that. We had overlap, we didn't want that. But by using inequalities, we don't have gaps, we don't have overlaps, which means if someone's exactly 30 minutes, we know straight away they go in there. Okay, now just in terms of the notation, it might look a bit confusing because you've got 11, you've got this T, you've got 20. T just means the time that they've spent. Okay, so this just means the time that they've spent is greater than or equal to 11, but the time that they've spent is less than 20. You might set up another one, okay? If it was a survey to see how much students weighed, okay? You might do weight, okay? You might call that W, frequency, and we might have 40, and we'll say that's kilograms, W, 50, and then 50, 60, and then 60, 70. So we might have 12, 3, 11. So if someone weighs more than or equal to 40 kilograms, but less than 50, so between 40 and 50, but it includes 40, doesn't include 50, they go in there. 50 to 60, and the W just means the weight is between 50 and 60. Their weight is between 60 and 70, but it includes the 60, doesn't include the 70. Okay, so I hope that helps. Thank you for the student who asked this question, but I'll send that to everyone. Hope that's been useful. Thank you.